Okay, now we're going to talk about a system called elimination method. Now, one thing you might want to know is these three methods, graphing, substitution, elimination method, generally are covered in one section. I just broke them up into three here for you. Okay, there's a very easy example here. You can read the instructions up here first if you want to pause the video. But basically what you're going to try to do is you're going to try to add equations together so that one of the variables will eliminate. Now this is an easy example because I don't have to do anything to this one to force a variable to eliminate. If you'll notice here, I have a minus y here and a plus y here. So if I add these equations together, x plus x is just going to give me 2x. And minus y plus y is just going to be 0. So I'm just going to get 2x over on the left side, and then when I add 3 to negative 1, I get 2. And then so you have 2x equal 2, so all you have to do is divide by 2 to get x. So we get x equals 1. And then just pick one of the equations that you want to plug the 1 back into to get the y value. So I'm going to use this equation. So I plug the 1 in for x, and I get 1 minus y equals 3. Then if I subtract the 1, I get minus y equals 2. And then if you multiply both sides by negative 1, you'll get y equals negative 2. So the answer is 1, negative 2. Now, this one I'm going to call a medium problem because on this one, you can get away with just multiplying one equation by a number. Now remember, when you take an equation in a system and you multiply an equation by a number, if you multiply everything by the same number in an equation, it's not going to change the answer. So if I were to multiply x plus 3y equal 9, if I multiply everything in this equation by negative 2, it's not going to change the answer. And now why did I choose negative 2? Well, I saw up here that I had a 2x. And I know if I add 2x to negative 2x, they'll cancel. So I thought, well, if I multiply this term by negative 2, that would give me a negative 2x. But I can't just multiply that term by negative 2. I've got to multiply all three terms by negative 2. So if I multiply x by negative 2, I'm going to get negative 2x. If you multiply 3y by negative 2, you're going to get minus 6y. If you multiply negative 2 by negative 2, 9 by negative 2, you're going to get negative 18. And now when I add these together, the x's just cancel, and I get y plus negative 6y is negative 5y. And then over here, 8 plus negative 18 is negative 10. And now just divide both sides by negative 5, and I get y equals 2 for the y value. And then all I have to do is plug this y value into one of these equations. I chose this one. So I'll plug my y value into that, and I get 2x plus 2 equals 8. And then just solve that for x. Subtract 2, and I get 2x equals 6. And then divide both sides by 2, and I get x equals 3. So the answer is the order pair 3, 2. Now, I could have, just to make sure you understand, I could have multiplied this first equation by a number to make this be negative 3y and add it to the second equation. So it's up to you which one you want to do. Now sometimes you're going to have to multiply both equations by a number. And if you'll notice here, I have 3x and 2x. So I thought, well, if I could make this be 6x, and if I could make this be minus 6x, then I could add them together and they would cancel. So I said, well, I'm going to multiply the first equation by 2. So I multiply everything in the first equation by 2. And then I'm going to multiply everything in the second equation by negative 3. And of course the reason is, look at what happens to the x. 2 times 3x is going to be 6x. And then minus 3 times 2x is minus 6x. Now don't forget, I have to multiply everything in the first equation by 2, so that's going to make that a negative 4y, and 2 times 8 is 16. And likewise, I have to multiply everything in the second equation by negative 3, so it's going to be negative 15y, and negative 3 times negative 1 is going to be plus 3. And then if I add them together, the x's will cancel, and negative 4y plus negative 15y is negative 19y, and then 16 plus 3 is 19. So I get negative 19y equals 19, and then divide by negative 19, and you get y equals negative 1. Now, we still have to finish this and get the x value. So I took the first equation, and I took this equation, and I know the y value now is negative 1, so I plugged that in, and so I get 3x plus 2 equals 8, and then just subtract 2 from both sides and then divide by 3, and you get x equals 2. I didn't write all the steps there, but I figure you can figure it out. So the solution is x equal 2 and y is negative 1. Okay, here's an application problem that we can do. A man wants to use milk and juice to increase the amount of calcium and vitamin A in his diet. An ounce of milk contains 37 milligrams of calcium and 57 micrograms of vitamin A, and an ounce of juice contains 5 milligrams of calcium and 65 milligrams of vitamin A. How many ounces of each should he consume daily to provide exactly 500 milligrams of calcium and 1200 micrograms of vitamin A? Okay, so the question asks how many ounces of each. So I'm going to let x be the number of ounces of milk and y the number of ounces of juice. Now, sometimes it's helpful to create a little table here. So I'm going to show you the calcium. For each ounce of milk, we get 37 units of calcium and 57 units of vitamin A. For juice, we get 5 units of calcium and 65 units of vitamin A. And the problem says we need 500 units of calcium and 1200 units of vitamin A. So if you take 37 units or times the number of ounces of milk, that will give you the calcium in the milk, and then 5 times the number of ounces of juice, that gives you the calcium in the juice. So 37x plus 5y is the total amount of calcium, and that has to equal 500. And then for the vitamin A, you multiply milk by 57, so 57x for the milk, and then for the juice, multiply that by 65, so you get 65y for the juice. And so 57x plus 65y has to equal 1200 units of vitamin A. Now this one, to solve this, I had to think a little bit. I have 5y, and here I have 65y. So I knew if I multiplied 5 by 13, I'd get 65, but I actually want negative 65, so I had to multiply by negative 13. So if I multiply everything in the first equation by negative 13, you can check this on the calculator, but it'll give me negative 481x minus 65y minus 6500. And then I can add the second equation to that, and then the y's will cancel. And when I add those together, I got negative 424 equals negative 5300. And then when I divided both sides by negative 424, I got x equals 12.5. So 12.5 ounces of milk. And then to get the juice, I went ahead and just went to the first equation, 37x plus 5y, and I plugged in x equal 12.5 there, and then I just solved this equation for y. So I got 462.5 equal 500. I subtracted 462.5, and I got 37.5, and then divide by 5, and I got 7.5 ounces. So basically 12.5 ounces of milk and 7.5 ounces of juice will satisfy the problem. The numbers aren't always nice. Take a look at this one. If you solve this system, let me just tell you, I multiplied everything in the first equation by 4, and then I multiplied everything in the second equation by negative 3. And I did that so that I would get a 12y and a minus 12y. But when I added them together, I got 11x here and 46 here. So I got 11x equals 46. But when I divide by 11, I get 46 over 11, which is not a nice round number. So then to solve for y, I went back to this equation and I plugged 46 over 11 in. And when you multiply 5 times that, I got 230 over 11 plus 3y equals 10. And then, so when I subtracted 230 over 11, I had to write 10 using a common denominator. So 10 is equal to 110 over 11, and I did that so I could subtract the 230 over 11 and keep it in fraction. So I got 3y equals negative 120 over 11, but then if you divide both sides by 3, the 3 will go into the negative 120 and give you negative 40, and give you negative 40 over 11. So the solution there is 46 elevenths for x and negative 40 elevenths for y. This is just a couple of examples of setting up. Go ahead and read number 1, but basically it's very similar to the one I did earlier about child tickets and adult tickets. It's a little bit different though. In this example, we're given the total number of tickets is 500, so x plus y must equal 500. And then we're given that the price per adult ticket is $2, the price per child ticket is $3, and that we got a revenue of $13.50. So 2x plus 3y must equal a revenue of $1,350. And we're just setting these up, but you should be able to solve them. The second one is manufacturing two types of bicycles, 3-speed and 5-speed. And you're told that you have 20 hours available to assemble the bikes and 33 hours available to paint the bikes. And it says how many bikes of each type must be produced each day to utilize all the assembly and painting time. Well, if you go back up here and look, first of all, let x equal the number of 3-speed bikes and y the number of 5-speed bikes. Well, remember, you only have 20 hours of assembly time available, and if you go back up here and look, it takes 1 hour to assemble a 3-speed bike and 2 hours to assemble a 5-speed bike. So 1x plus 2y would be the assembly time, and that has to equal 20. And then for the other bike, the 5-speed bike, I'm sorry, not the other bike, the other constraint here is the painting time. It takes 2 hours to paint a 3-speed bike and 3 hours to paint a 5-speed bike. So right here we have 2x plus 3y equals 33 for the painting time. And so that's just a couple of problems, a little practice of setting up some of these word problems. I wanted to show you when you have a dependent system, you can actually take it a step further than just saying you have a dependent system. So let me just show you this system. If I take this first equation and multiply it by -3, then this is what I'm going to get. And when I add the two together, I actually get 0 equals 0, which is a statement that's always true. So that tells me that I have a dependent system. Well, what it means is when you have only two equations and two variables, that means that those two equations represent the same line or the same equation. So I'm going to take the first equation and I'm going to solve it for x in terms of y. So if I solve for x in terms of y, I get 2x equals y plus 5. And if I divide both sides, everything by 2, I get x equals 1/2 y plus 5/2. Now, that means that for any y value you give me, I can get an x value. In other words, x depends on y. Now, I can't list all of those values because you could give me infinitely many y values. But what I can do is I can show you the solution set. So the solution set would be y is just y, and then what's x? X is based on y. So whatever you put for y, x is going to be 1/2 of that plus 5/2. Now, you can use y here, but you don't have to. You can use any variable you want because all you're doing is describing how these two variables are related. So if I said y was k, then x would have to be 1/2 k plus 5/2. So anyway, this is the way that you can write the solution set for a dependent system. And then down here I just give you a note on calculators. But if you solve a system using calculators, make sure you understand the algebra, because calculators are great as far as solving systems and graphing, but there are a few things you might need to know about them, and so you might want to Google some stuff on YouTube about calculators and graphing and solving systems.